Hello world, welcome to Gamedev the Hard Way, my ongoing attempt at creating a game from scratch using C for this thing. It's called an Agon Light. It's a single board computer inspired by the BBC Micro. It's got an EZ80 CPU, it's got an ESP32 that handles video and sound, and then it's got 0.5 MB of memory. Last time I made sprites work. This time they're getting somewhere to explore. A game is a bit rubbish if the character just moves around a black screen shooting at stuff. That might have been good enough 30 years ago, but today we've become accustomed to game worlds that are a little bit bigger than the screen. We're also looking at the process I went through to design the game. I'm obviously English, in case you'd not noticed. We have a bit of a history of hiding in our bedrooms and knocking out software on an evening. This series is my attempt at capturing that feeling. Some guy by himself, figuring out how to make a complex piece of software for a very limited computer. Not quite sure whether he's even capable of finishing it. And you're coming along for the ride. So, let's go. I'm not a game designer, but I've met a few, and watched a few hours of GDC talks and read some interesting stories of how some of my favourite games were made, so clearly I know all about this process. Let's see what I've learned. So, we're supposed to construct a massive game design bible detailing every single part of the game in minute detail. It's supposed to totally define the whole game and be checked for consistency with the IP of the game and the demographic of the gamers we're making this game for. Should take months and months, involve multiple rounds of concept art and focus group meetings, right? No? Bit too much? Not back bedroom coder enough? Yeah. So I should just start hacking at my code and beating out some random idea and then shoehorning a game into that? Bit too hacky? Yeah. Maybe then I do months of rapid prototyping to see if any good ideas come out, produce a few paper prototypes to test game mechanics, and again get distracted cosplaying as a real game dev because I own a compiler. No, it seems a bit crap, that idea, really, doesn't it? How about we just flail around and try and find a happy medium? Something with a bit of direction, but loose enough I can have fun and play around, since I'm some guy making a thing in his spare time and not taking much of this that seriously, you know? I'm also working on this in my spare time, so I'm not doing sprints or cycles or anything else that gives me a consistent week of time to work on a feature. I might grab a few hours here, a few minutes there, forget about it for 2 weeks, and then have to remember what I was even doing because I told the internet I was making some games the hard way. Turns out making games at all is the hard way, and just buying them from shops is the easy way. Why do we do this to ourselves? So, to try and keep this going, let's steal from other people. Let's look at what the professionals do, specifically the ones who didn't realise they would become professionals. One even trekked off in the snow to collect his new computer and locked himself in a room until the code works. That sounds like my kind of thing. So, I found this thing, which claims to be the Doom Game Design Bible for the original version of Doom for DOS. So here it's detailing what the intro and demo loop will be. There's going to be a control panel that apparently has clever integral menu. I guess they hadn't thought that up at the time, which is interesting to know. They're going to be a new 3D engine, which again, I guess they didn't know at the time what they were going to do. So it's nice to see that there's bits in this design document that they didn't know. They're like, it's going to have a 3D engine, we'll figure that out later. There's going to be a menu as well, don't know what that is. Here it's detailing a load of characters. Now if you've played Doom, you know it's got 4 people in it. But they're just like different colours, and they don't have any story to them. So here's the supposed story of Doom, which if you've played Doom, it's kind of vaguely sort of a bit similar, but you don't get told any of this, and some of the names are different. It's got humans, imps apparently fly, which they changed their mind on, I guess, by playtesting it. But you can see that all of this is just kind of helping them have some sort of guide on where they're going. It's not the game. The game deviated from this quite a lot. They've also listed all the graphics that are needed. So this is obviously designed for many people working in a team to be able to work on together. They can then split this up between them. It's just me. I don't need this much detail. I just need to have something to keep me on track so that I don't forget what I've decided to do and I don't overdo something. So this is what they wrote for Doom, as far as I can believe. I'm now going to show you what I've come up with for my design of my game.
As I no doubt just spent far too long explaining, I need a plan, but I don't want to overplan and cosplay as some sort of wannabe game designer and never get around to making a game. Except I also don't want to spend months of my life pissing about pretending to play at Gamedev and achieving nothing but a twiddly little minute bit of nonsense. So behold this amazing work of fiction. Now, I'm not naturally gifted with much imagination, but I think this is okay enough, and it's definitely 80s video game quality. You could imagine this written on the back of some box trying to entice you to play the game. And oh, for those of you that aren't actually looking at your screens, the basic story is that it's the near future. The energy crisis has caused humanity to explore alternate ways of generating energy. So there's a space research station that was launched last year. Its mission is to orbit the sun and do research on ways of better capturing solar energy. 6 months ago, the station's onboard AI went a bit weird. So you're some engineer that's been sent to the station to find out what's gone wrong. And you dock with it, it lets you on board, and then it starts telling you that the station is a bit broken and it's going to fall into the sun. I know it's kind of like Z-grade quality GCSE, not even that English story, but never mind. It's a beginning point. The story has given me a structure, and that's its function. The other structure to help guide the game's design are hardware constraints, and on an Agon Light, we've got these things. The hardware is quite limited. I've got a 320 by 240 screen of 64 fixed colours. I don't have a palette, I've just got 64 colours. Screen scrolling is hard to say, it's also slow and difficult. I've got a 4-way joystick and some buttons. Everything needs writing from scratch because that's kind of the point of this whole series. I'm making my life difficult on purpose. Now with all those constraints and a sort of story type thing, it's getting easier to structure some of the basic concept for the game. This is also where I can mash together existing game ideas from things I've played. Now, it's also good to steal. I mean get inspiration from existing games. I mentioned Doom quite a lot. It's a fun game. It's one of my favourite games as a kid. It was one of the first games where the scenery was more than a background to run about on. It felt like a world. Okay, a world full of weird liminal spaces that made no literal sense. Like in this image, is this some sort of demon meeting before work? Are some of these Baron of Hells being given like the stand in the monster closet shift for the day? Now I'm writing this game on pretty limited hardware, but that doesn't mean the game has to be limited. I never got on with Zelda as a game, it just didn't click with me. But I do like the way the large world is there and you can explore it. That was a unique thing with 8-bit machines. After all, I said I wanted to make more than a bog standard shooter. I played loads of Portal and Portal 2, and some of the best fun I had was figuring out how to beat a level simply by running past things instead of doing it properly. Why go to the effort of engaging with an enemy when you can just run around it? That's what you could do in this game. I didn't play it much, but I quite like the general theme, where it's sort of high-tech sci-fi stuff, and there's a bit of stealth involved, and there's hazards that you have to avoid. It's not just mindlessly shooting things. There's a bit of a theme with this game that I want to make. So here's my general concept what this game should be. It's going to be a top-down flick screen tile-based game. Bit like Zelda, where you walk to the edge of the screen and the next part scrolls into view, or it just appears. I don't quite know which bit yet, but as you'll see later on, I've got something that kind of gets the idea across. I'm going to have different levels for you to explore. Exploration is going to be a thing in this game. I quite like games where you're not just trying to get from A to B to get to the next level to do the repeated thing again. And I want you to be able to move between levels as they're discovered, so you're not locked into having to complete level 1 before you can get to level 2. Maybe you get all the way to the end and then realise it's too difficult and you've got to backtrack through the game to improve or do something else first. And I want the world to feel alive. I want it to have things to interact with. So maybe like switches or sensors or doors or whatever. Because then that gives me the potential to build interesting puzzles. And I don't want it to just be a mindless action shooter. Which leads me actually to being able to define the gameplay. So now I've had a story and I've got some constraints, I can start to figure out a bit of gameplay. I've got these general sort of ideas. You're going to explore each level. You need to find the exit to the next level. But along the way, you're going to solve puzzles to help you get through the levels. There'll be some various hazards of whatever description to avoid. and the player is going to be able to do the following things. They'll obviously be able to move around. It is a game after all. They'll be able to activate and interact with the scenery. There might be an element of stealth or having to quickly escape something. And the ability to shoot. But if you do it, I want it to somehow like turn everything hostile and make the game really, really difficult. To kind of give you that ability to shoot your way through something if you really have to. But if you don't, maybe you can just like creep around and avoid it. So something I learned ages ago in some random book was that there should be gameplay loops. This is not a programming concept, this is a gameplay concept. That there are sequences of what you do in the game, and they should be at like different levels, and they sort of layer together to make a more interesting gameplay experience. You're not just doing one repeated thing. There's like a core thing that you do, but then it builds into something else that's bigger. So I'm going to have a sort of main game loop where you've got to complete levels to get to this AI core. You've then got to reset it, and then you win the game. Or there's some alternate ending or something. But then in each level, you're going to have to explore the level and solve puzzles, discover some more story, and interact with the level so that you can use the exit. And then there's going to be a bigger loop of a story where you have to find clues and station logs and explore and generally figure out what's going on so that you can kind of build up a bit more of a world that you're playing in. It's not just going to be like static levels that are a bit like a kind of lab that you have to get to the end of. But enough waffle. That's the game design and what I want the game to do. So here's a plan of how I intend on going about this. Instead of trying to build the whole thing, I'm going for what they call a vertical slice. It's a complete experience of the game with one functional level. So now we've figured out what I'm making, I think I'm going to talk at you now about what I've been working on recently. I believe it's the multiple screen tile map system. So let's go see what other me is going to waffle on about.
Actually, no, we're not. Before I go rambling off into the code, let's actually look at what I'm trying to do today. To make a game world larger than the screen, I first needed to figure out the actual screen resolution. Like when you look at the screen on a, in this case a very old yellow TV, you need to know how many pixels across and down it is. The Agon Light has different video modes. There's quite a few. The best one for games is called Mode 8. It provides you with 64 colours and 320 by 240 pixels. So with some basic maths, it's not hard to see that if I choose a 16 by 16 pixel tile, I can get 10 tiles across and 15 tiles down on a single screen. And this is fine, you know, single screen games are okay. We've done them for decades now. But I want more, like big chunky sprites on a single screen is a little bit too 1980s. When the screen is only 320 by 240, a 16 by 16 pixel looks quite big. So I want to give the illusion of there being more world to look at, so that the player can walk around beyond the screen boundaries. And that's what we're looking at today, how I managed to make the game world larger and span multiple screens. As you can see, the player can escape the screen boundary and investigate more of the level, and apart from some minor graphical glitches that I'll talk about later, the whole thing is rather performant. It's not destroying the performance of the machine. Like my previous scrolling level demo, if you've seen it in a previous video, it looks quite nice, it scrolls left and right, but it's a little bit of a trick. It's like those demos that you've seen that look amazing and you think, why don't they put this in games? Well, they usually don't, because it's all the computer can do at once. There's not a lot of CPU left over when I'm scrolling the screen. This though, as you can see, the player moves around nicely, can go off the screen, can come back on it. The screen looks big enough. It looks quite nice. We can build a game from this. Now before we get to the code, let's go through a few concepts necessary for this thing to work. Don't fall asleep, this bit's important or the rest of my explanations will be complete garbage. They were largely garbage before I started turning my brain on and explaining them better. I've got about 20 outtakes of this stuff. Future me goes off on one for a bit about how this code works, completely forgetting there's a load of different things that he forgot to explain. He does get a bit easily excited when his code works and he just starts talking nonsense. Brain goes into autopilot. So let's help him out by explaining what's going on before he starts waffling. Here we go. So we know how large the screen is and the size of the tiles. Making a bigger game world is mostly just a case of literally creating a bigger tile map. I used TileEd and I just sort of copy pasted my single screen tile map a few times to make a larger one. I didn't really give it much thought.
The dimensions I picked are a little bit random, like the whole map fits into a 1920 by 1080 screen, because in my brain at the time I thought that sounded like a good idea. I thought I was going to be able to edit it easily with it fitting on a whole screen, but I completely forgot that TileEd has menu bars that take up screen space anyway. So, you know, whatever, we have to pick something. But after running about in the level for a bit, it feels big enough, it feels like a decent sized game world. If it turns out to be too small, I can always make it bigger. I've not hard coded any numbers into my code. It just literally reads the tile map and then figures out the rest. I needed to do a couple of things. I needed to figure out a way to use this large tile map and also invent some words to describe the different things being manipulated in my code so that variables made sense and just my whole understanding wasn't getting confused. So what I decided was this. The whole map is called a map, obviously. Every tile on the map has a coordinate that goes from 0, 0 in the top left corner all the way down to something like 119 by 66 in the bottom right. It's important to know the tile's coordinates for collision detection. So that's the individual tiles in the entire massive tile map. The thing you look at the game through is equally obviously called the screen. I know, right? And they said naming things was hard. The game has got objects, which is like the player and whatever. We'll talk about them later. TileEd has its own coordinates for those, which we're going to make use of. And the screen is 320 by 240 pixels in size. To draw anything on the screen, I need to convert whatever internal made up by me late at night coordinates or TileEd's internal coordinate system into an actual physical XY pixel location. So we have screens and things. What do we call the screen size bits of map that we look at? Like, if you look at the video now, you see how the player goes off the edge of the screen and a new bit of map appears? We need a name for those pieces. We can't call it a screen, because that'll confuse the shit out of me later. And after far too much thinking, I decided those bits of map should be called chunks. Minecraft calls bits of its large map chunks, so it seems like a decent name. Each chunk has an index, so I know where it is on the map. They go from 0, 0 in the top left to 5, 3 in the bottom right. Knowing which chunk is currently on the screen is important, as is knowing which chunk the player is trying to stand on. Like, I've got to make sure if the player goes off the screen, the next screen appears with the player on it. The player should always be on the screen. They shouldn't be able to like disappear. So now we have a map made from 24 screen-sized chunks. And each screen-sized chunk contains 20 tiles across and 16 tiles down. So the game needs to work out which of those chunks is to be drawn on the screen. By doing some maths that is very easy, but took a while to get my head around, we can convert between these different coordinate systems. I can choose any random chunk and figure out which tile is the top left tile of that chunk and start plotting all those tiles on the screen. Or I can choose any random tile on the map, work out which chunk it's on and draw that chunk on the screen. This is fine, it only hurts slightly to think about. So now I need to tackle the objects in the game. TileEd allows you to place objects on the map. It's one of its really useful features. I don't have to hard code or work out coordinates in my brain. I can literally click on the screen and say where I want things to be. And it's got its own coordinate system for those, that for some really insane reason is stored as a floating point number. The documentation says the coordinates are pixels from the top left corner. So why has it got fractions? Like, you can't get a fraction of a pixel. Okay, on the screen I can zoom way far in, but you see as I go from one pixel to another, it's just the whole number bit that's important. But I don't know, I don't care, I just shove that number into my fixed point maths code and it works. And using some more elementary maths that a 12-year-old would find easy, and yet I find somehow weirdly hard to comprehend. Don't know what it is about this basic style maths that I find difficult. I can write 3D maths and matrices and all that kind of garbage, that's pretty easy. But basic division and multiplication, I get it mixed up all the time. But I can now take any random XY position in the whole map and work out what tile is under it, which is good for collision detection. And I can also work out where that position would appear on the screen if I drew the chunk that it was part of. The only other thing to do is figure out how to draw an object on the screen properly. Objects can have a coordinate that goes from 0, 0 to something like 1919 by 1071, or whatever's in the bottom right corner of the screen. That's what tiled stores when I put objects on the screen. So the first thing we have to do is figure out the chunk that the sprite is on. Then remove that offset from all its coordinates. Intuitively, it makes sense, right? If the player is in the bottom right chunk, which is chunk 5, 3, we need to subtract 5 chunks worth of 320 pixels from the player's X coordinate, and 3 chunks worth of 240 pixels from its Y coordinate. But we first need to know that we have to remove 5 and 3 from those two coordinates. And then we draw it actually on the screen at those coordinates that we calculated. I worked most of this out by drawing diagrams and talking to myself quite a lot. Writing the script for this section had me severely confused as I looked at code I'd written before and couldn't quite understand why I'd written it. So if you're looking at that thinking, what are you on? We solved this 30 years ago by doing these 2 really simple pieces of maths. Why have you done this complicated thing? Please show me a better way. However, if this is actually the way it's supposed to work, let me know too, because I like to know if I've done something right as well as doing it wrong. You know, I'm mostly just figuring this stuff out from first principles and drawing things on paper. If it works, and it doesn't suck, I consider it good enough, and I move on to something else. So, with that in mind, let's move on to something else and see how this works in code. So this is a walkthrough of how the game screen works, which is the main thing that you look at when the game is playing. So it has this initialization function, and it does basic things to set up the screen. Part of it is calculating how many tiles there are per screen. This is so that it knows how big a chunk should be, and a chunk is just what I'm calling a screen's worth of tiles. There's then this for loop. What this is actually trying to do is find the player, because it needs to draw the player on the screen and then make sure that whatever chunk the player is in is the screen that you're looking at. I'm doing a bit of a test. I'm actually looking for the exit and spawning the player at the exit. The idea being, I've always been testing this with the top left corner of the map, and I actually want to check whether it's even drawing anything but the top left corner of the map, and that all the collision detection is working correctly. I had this horrific thought that maybe I'm colliding with only the top left corner of the map, even if I'm seeing something different. So this just lets me get the position of the exit and put the player there instead. So this section of code, like it says, just finds out which screen or chunk that the player is on, and then ensures that that chunk is the one that is actually visible on the screen. There's a lot of code here that converts different coordinate spaces between them to work out which chunk we're in and where the top left tile of that is, so we can draw it on the screen, blah blah blah. I've gone into detail about that before, I'm not going to repeat it. It then draws the tile map. And this is the only time the tile map is drawn on this screen. It isn't redrawn every single frame. I draw it once and then I use dirty rectangles techniques to just patch in the gaps where the player has been. This saves a lot of time and effort. I've then got 2 variables. This transition state is trying to work out whether we're trying to switch between different screens. And if we are, it's going to do some extra logic. This is just to test if the game is over. The game update function just has a few little things in it at the moment. I can kill the game instantly by pressing X. If it's game over, go out to the title screen. So this code here is a bit slightly wonky logic. I need to rethink this. I'm just trying to make it work. The idea is that if the player is not visible and we're not switching the screen, then that means we've just walked off the edge of the screen and we've not yet started processing that. So we're going to set this variable to say we are switching the screen and that we're currently in transition state 0. So I've got a little state machine running, which I'll now go and show you that. So this horrific bit of code is an attempt at a very badly made state machine. I'm trying to get it where I can switch between the different screens and have a little bit of time between them to do some kind of switching animation, like in Zelda where it scrolls the screen sideways. So it's got 3 states. The first state, it's simply just going to clear the screen and then move to the next one. The next one was supposed to have a timer to kind of make it take a few milliseconds or frames, just so it wasn't instant. Then it was going to go on to the final state where it's supposed to redraw the tile map and put the player back on the screen and everything. This bit works, but you can tell from the amount of debugging that I was getting a little bit confused with it. there's fixed point maths in this, I'm converting things between different world spaces and things. It was confusing. This is also the only other place where it draws the tile map. Finally, this is the code that draws the screen. It barely does anything. You see, it says if the player is not visible, but we are switching a screen, call that level transition function. Otherwise, print game screen just so I can see there's some text, and draw the sprite system. And that's it. It's not doing anything else each frame. It's just very minimal drawing to the screen. That pretty much is how the whole screen is working. Now behind the scenes there's a lot of extra things going on. So what we'll do is we'll now go and look at the tile map functions to see how I've changed those a bit. So this is a code to draw the tile map on the screen. It's slightly modified from before in that it now takes in a point, which is just an XY coordinate of the current chunk we're trying to draw. It works out the overall width and height in tiles of the whole map. It then sets the current chunk that the entire game is using to be whatever we passed in. And then there's just this double for loop that is physically drawing the pixels on the screen. And it's using all these various X and Y positions to work out which specific little pieces of image are getting drawn on the screen. Now, some of you have asked before where the actual pixel drawing happens. I'll show you what's inside this VDP plot bitmap, because I think it's a bit confusing if you've not seen how an Agon Light works. So if you're not used to an Agon Light, it has a screen that is kind of like a bitmap, but you can't draw directly to the pixels of that bitmap. You don't get this big block of memory to go and play in. Instead, because it's done on an ESP32 that's separate to the Z80 CPU, they're connected down this little serial connection. So all you can do is send it commands. You're not sending pixels, except when you first set the system up, where you do upload all your bitmap graphics into the ESP's memory. When you do that, each separate graphic is given its own separate buffer ID. So all the separate tiles have their own separate little square of image, and they've all got a separate number that identifies them. So to draw one of those on the screen, I need to know what its ID is, and then the coordinates of where I want to put it on the screen. And then these numbers are the commands to tell the ESP, which runs this thing called FabGL, how to draw this on the screen. So there isn't actually any direct pixel access going on. It's kind of all second-hand. Could you please draw bitmap 16 at these coordinates? Could you then draw bitmap 20 at these coordinates? That's all it's doing. That's why this plot bitmap is looking for an offset that I've got so that I know where my bitmaps start from. And then it's just looking for the index in the map of which tile to draw based off the coordinates of where I am in the screen, or in the whole level even. So if I look at the map data, which is actually just a piece of data that I can load in, so it appears I can't find the binary version of this data, but here is the raw tiled XML file. As you can see, I've zoomed out, and conveniently my editor will highlight all the same value. So you can now visually see what the whole map looks like. So each of these sections is one screen's worth of tiles. That's what I call a chunk. So I just need to know if I'm in this one, I need to know where its top left corner is, so I can draw that on the screen and pick out all these tile IDs. And there's that giant big pointer that comes from Wayland. Look at that. It gets bigger and bigger and bigger the more you do it. The size of that pointer, that's ridiculous. I wish Windows did that as a random thing. I keep losing my mouse pointer in Windows. Very annoying. Here I just do this and it gets bigger. But anyway, this is the whole map. I've spoken about the map before, so there we go. So as you can see, drawing the tile map is still just like it was before. I now just have to pick out different tiles from this very large tile map. The next part of code that I updated was also the sprite code, because that needs to cope with the fact that the screen is bigger than it seems and that there's different things that you might collide with when you're off the screen. So let's go look at what I did with that. So to cope with the various updates that I've done, I've been refactoring the code. I'm making this up as I go along, so, you know, I change my mind and see what works and things stick and some things go away. What I needed to do was adjust how the positions work. Before I was doing all this tile map stuff and it was just a single screen, I just needed to know where the sprites were on the screen. Now I need to know where they are in the entire world that isn't just the screen. But I also need to know where they were on the screen so that the dirty rectangles code is working. So, like I've explained before, I've got different sort of spaces that I'm calling them, different coordinate systems. So this is the overall global position of the object in what I'm calling object space. But then I've got two separate points that are its last screen position and its current screen position. But this is the physical position on the screen in actual pixels. So the screen is 200 and something by 200 and something else. I'll put the right numbers on the screen. And that's literally what pixels this image is on. So this is still testing whether we're working with a tile map, and then we're getting rid of inactive and non-physical sprites. I don't have any of them yet, but we might do in the future. We're then still working out which tile the sprite is overlapping, like before. We're working out the top left X and Y and the bottom right X and Y of what tile the sprite is over. And then this nice little bit of nested for loop, because everyone likes nested for loops for destroying the speed of their code, but there's no other way of doing this. We're just trying to work out what tiles the sprite is overlapping to work out if it's a wall tile which is supposed to be solid, so that we can get the physics system to resolve the collision so it is solid, and move it out the way. And that's all that piece of code is doing. It looks far worse than it is. Just because there's lots of multiplies and extra things going on inside it. This piece of code still deals with sprites that collide with each other using axis line bounded boxes and resolves the collisions for that. That has not changed. What has changed is this piece of code here. So there's like several phases that this thing goes through. First, it updates the physics, if there is any, and it does a physics integration. It then deals with map collisions to resolve those. It then deals with sprite collisions to resolve those. It then runs the logic for the sprite. So if there's an update function, so inside player.c, there is a player update function, it runs this code here. Once it's run that code, it updates the position of the sprite from the physics body to make it move around the screen. These sprites I'm allowing to move when they're not visible on the current visible part of the screen. I don't like the idea that games cheat and the creatures and things that are off the screen don't move until you can see them. I want them to still go about their business even if you're not watching them. It makes it more realistic, because if you go off the screen and come back on, the sprites haven't just patiently waited for you to come back. They've continued wandering about. I want things that follow you through the game, trying to find you, because then I can do some pathfinding algorithms, which will be quite fun. So that means I need things to move off screen. But then we get into some slightly confusing logic here. Because we need to save where the sprite was on the screen. We then need to move it to its new position on the screen, which means converting its fixed point position that the physics system created into the actual physical screen that we're looking at. We're then checking if that's the actual current chunk that we're looking at. So is this a sprite that's actually on the screen? If it's not, we mark the sprite as invisible, but we still update it. So that's what this piece of code is doing here. It's all working out, are we even using a map? And if we are, is the sprite that we're currently using visible on the current map that we're looking at? If it is, we set visible to 1. If it isn't, we set visible to 0. Now, further terrors await us in the drawing code of the sprite system. Because we're doing dirty rectangles, which is where you take a picture of the bit of screen you're about to draw the sprite on, draw the sprite on the top, and then when you move the sprite, you cover it back up with what you've just used and move the sprite somewhere else. I need to do something a little bit different for the edges of the screen. So this is where the bugs are that I need to look at. So I've got this idea of this thing called a dirty buffer, where I just take a capture of a sprite-sized piece of the screen. What I'm supposed to do is just like capture that and then paste it back over later on, which works fine when you're on the screen. But if part of the coordinates I'm trying to capture are off the screen, it seems this VDP capture bitmap function doesn't quite function like it should do. So I've got some very suspicious code here that's just trying to make sure that I'm not going to capture coordinates that aren't visible. Once we've attempted to clean up where the sprite was, we then draw the sprite in its new location. So if it's active and it's visible, we draw it at its current position, and that's it, job done. And that's about it. So it doesn't look like much code when you see it, which is one of those irritating things about writing code. It takes hours to figure this stuff out, and you spend lots of time with it just not working or not compiling, or you're fixing stupid little syntax errors that you didn't know you'd made. And then when you look at the code you've produced, it's just like 10 lines of code and it seems to work. And as you see, when I wander around the screen, if I get to the edge of the screen, it just kind of goes on to the next one. It's not doing anything that clever. I was actually pretty surprised any of this worked. But I do need to look at this in a bit more detail. And this is also a gameplay thing. I was going to have some sort of moving tiles animation to make it happen. But actually, it just flicking between screens doesn't seem that jarring. It just seems to make sense if like there's a little black flash and the next screen appears. Your brain kind of figures out that you've just changed to a different screen. So I might just do it like they do in Zelda, where if you walk off the edge of the screen, you don't actually leave the screen. You just get to the screen boundary and then it moves the screen for you. And I think that will also fix all this smeary graphics problem that I've got, because you'll never leave the screen, so I don't have to deal with that problem.
I grew up playing games on my ZX Spectrum and Atari ST, assuming games were made by giant companies, like how movies and TV were made, and that a normal person couldn't make them, that we mortals were restricted to making crap in BASIC and being happy about it. Remember those amazing Usborne books and how pretty much all the games in them were text-based and pretty non-interactive? Yeah, I just assumed it was the limit of what a home programmer could even do. Then I saw magazine interviews with people like Jeff Minter, and later learnt many of the games I liked playing were made by a few people in tiny offices or back rooms, literally winging it and hoping for the best. And I kind of realised that normal people could do this stuff too. It's just I was a kid and I didn't have the motivation or access to the internet, so it was very, very difficult. Later on, someone once told me Gamedev is like pinball. Your reward for doing well is that you get to do it again. While I don't think I want to put my house on the line trying to make and sell games, it's kind of fun to do it in my spare time. I was a regular reader of various blog posts in the early 2000s where the key Linux kernel developers would detail their attempts at making bits of hardware work. And when I found the book Masters of Doom, the story was quite compelling. The idea of locking myself in a room for a few hours and producing working code really is quite appealing. The point is, to all this waffle, the journey was often really interesting. The end goal was just that, the end. The process was what I wanted to know more about. Who else was a kid in the 90s? And the idea of staying up all night writing code and solving problems in the quiet and the dark sounded really cool. Me too. Being an adult with a job and having to get up at 6 AM is quite annoying. It gets in the way of all that stuff. In here though, I can sort of capture that kind of experience in these videos, whether it's me writing this game or the videos where I play around learning DOS stuff. What I'll try next is making more of these Agon videos, but do them sort of vlog-like. So not hours of quick scrolling code and time-lapse that no one really looks at, it's just there to distract you, or random code pasted on the screen while I waffle over the top. I think I'll use you to explain what I'm doing in the moment, bring you along for when things don't work, and when I actually get something running properly, you can be there to see it firsthand rather than some sort of scripted retelling. So if that sounds like your kind of thing, consider subscribing, especially since you made it to the end of the video. Well done. I'm also in the process of updating my website eventually to contain less dead links and make it generally a little bit better. So look out for that as well. But next time, there'll be more DOS programming. So I'll see you later.